Hello everyone, welcome to my channel Learn and Master Math. In this video we will be solving question 7 from May-June 2024, Pure Math 1. In the diagram, AOD and BC are two parallel lines. So here we have BC is parallel to OD, AOD straight line. And the arc AB is part of a circle with center O and radius 15. Angle BOA is equal to theta radians. Arc CD is part of a circle with center O and radius 10. And the angle COD here is pi by 2. Should have pi radians. Show that theta is equal to 0.7297, correct to 4 decimal places. So we have to find the value of theta here. As you see, because BC is parallel to AOD, we have an alternate interior angles. Here we have CBO is equal also to theta. And OC here is a radius, so it's equal also to 10, which is the same as the radius OD in the circle COD, quarter circle. And for OB, it's equal to the radius OA. This is also 15 here. Now we have the opposite and the hypotenuse. We can find sine of theta. So sine theta is equal to 10 over 15. And then if you want to find theta, just you have to make sure your calculator is in radian mode and do the inverse of 10 over 15. And then you will get 0.7297 rounded to 4 decimal places. In part B, they are asking us to find the perimeter and the area of the shape ABCD. Give your answer correct to 3 significant figures. So when we find the perimeter, all we have to do is to add the outer sides together. And in this case, we have OA. So the perimeter is OA plus the arc AB plus BC plus the arc CD plus OD, which is the radius in the second circle. OA is equal to 15. Arc AB, we already got theta in the previous part. It was 0.7297. So we can find the arc using the formula r theta. Make sure theta is in radian. BC, here we have to find BC using Pythagoras theorem in the right triangle here. So because these two lines are parallel, I mean BC and AD, this is also 90. Alternate to this one. Okay, and we need to find BC, so it's equal to the square root of the hypotenuse square, which is 15 power 2, minus the side here, CO. So CO square, which is 10 square. Now we are done from BC. CD, also it's an arc in the second circle of radius 10. So I'm going to use also r theta. This time r is 10 and theta is pi by 2. We are still having OD. OD is 10. And here instead of r theta, it's equal to 15 times the angle we got, 0.7297. If you do this calculation here, you will result with the answer 62.8 centimeter. Now we still have the area of this shape. So as you see, we have three pieces, like we have the sector AOB. So the total area will be the sector ABO or AOB plus the triangle BCO and the sector COD. As you know, the area of a sector is half r squared theta. The area of a triangle is half BH, and the second sector half radius 2 squared theta 2, which is pi by 2. Let's substitute. We get half. The first radius is 15, so 15 power 2 times the first theta 0.7297 plus the base here and the height in the triangle is 10, and we got this answer here 5 root 5. So it's gonna be half 5 root 5, which is BC times CO times 10. And in the second sector, COD, it's half. The radius here is 10, so 10 power 2, and the second angle is pi by 2. You do the calculation and you will get 216.53. The answer they need here is correct to three significant figures. So if you approximate this, it's going to be 217 centimeters squared. In question 8, we are given the first three terms of an arithmetic progression. A1 is 25, A2 is 4p minus 1, and A3 is 13 minus p, where p is a constant. Find the value of the 10th term. So we need to find A10 of the progression. First of all, I'm going to find p, using the fact that the common difference is equal to A3 minus A2, and it's also equal to A2 minus A1. If you start from here and substitute the terms in their right places, you will get a linear equation with a variable p. A3, which is 13 minus p, minus A2, which is 4p minus 1, is equal to A2, which is also 4p minus 1, minus 25. Swapping this doesn't change the answer. 13 minus p, I'm gonna remove the parentheses here, so it's gonna be minus 4p plus 1 equal to 4p minus 1, and minus 25 is minus 26. Arrange your equation. I'll take p to the right and numbers to the left. 13 plus 1, which is 14, and 26 here. Just move this. And 4p, we have negative p, negative 4p, which is 5p here. Okay, so 4p and 5p is 9p, equal to 40. If you divide by 9, you will get p equal to 40 over 9. Now, after you find p, you have to go and find the common difference. Because as you know, A10 is equal to the first term, A1, plus n minus 1, which is 10 minus 1 in this case, n minus 1 times the common difference. So we need the common difference. And to get the common difference, I'm first gonna get A2 and subtract it from A1. So first A2 is equal to 4. We got P now, so we can replace it with 40 over 9 minus 1. And if you calculate this, you will get 151 over 9. 151 over 9. Now the common difference D is equal to A2 minus A1, which is 151 over 9 minus 40 minus 25, which is A1 minus 25. And you calculate this and you'll get minus 74 over 9. Now after you got the common difference, you go back to A10 and substitute all the data you have here, which is A1 is 25 and minus 1. This is 10 minus 1, which is 9 times the common difference, which is minus 74 over 9. Calculate this and you will get negative 49. Now, question 8 part B, we have the same first three terms, but this time our sequence is a geometric progression. And he's asking us to find the sum to infinity of the progression. So we need S infinity, which is equal to the first term A over 1 minus R. And in this case, we need to find the common ratio R, which is equal to A2 over A1, and also it's equal to A3 divided by A2. So from this equation, I'm gonna start and substitute the data here. So we get A2, which is 4Q minus 1, divide A1, which is 25, equal to A3, which is 13 minus Q, divide A2, which is 4Q, minus 1. If you do cross multiplication here, you will result with 4Q minus 1 square, and this is equal to 25 into 13 minus Q. Expand your work here and you will get 16Q square minus double 4Q, so which is 8Q times 1, and plus 1 square equal to distributive property on the right, 25 times 13, which is 325 minus 25Q. You will result with a quadratic equation. Don't forget that Q is positive, so that's an information to keep in mind. So for your quadratic now, if you arrange your work, you will result with 16Q square plus 17Q minus 324 equal to 0. And if you factorize this, you will get Q minus 4 into 16Q plus 81. Solving each factor equal to 0, you will result with Q equal to 4 or Q equal negative 81 over 16. This one is negative, so it's rejected, and as we know that Q is positive. Now for this Q, I'll find R. You can use any of these ratios, or A2 over A1 or A3 over A2. So R is equal, I'm going to use A2 over A1 and substitute A2 for A2Q by 4. So 4 times 4 minus 1 divide 25. If you calculate this, you will get the ratio 3 over 5. Now we have the first term and we have the common ratio, so we go back to S infinity. S infinity will be in this case A1, which is 25 over 1 minus 3 over 5. If you do the calculation, here you will get 125 over 2. Question number 9. We are given this figure, and the diagram shows part of the curve with equation y equal 1 over 5x minus 4 to the power third, and the lines x equal 2.4, y equal 1. The curve intersects in the line at 0.11. Find the exact volume of the solid generated when the shaded region is rotated 360 about the x-axis. Well, as we know, the volume formula, the volume is equal to pi integral from a to b, the boundaries on x-axis of y squared dx. Y here is the function of x. Okay, so here, if I do integrate using this formula for this curve y given here, I will get the volume for this shape. Imagine with me, this is rotating around the x-axis. Okay, and then this will be the volume of this shape in here. Okay, I'm gonna try to do the symmetry here. I know this is not accurate 100%, but this is the volume you will get by just doing this integration for the y curve. And if you do rotate the curve y equal to 1, which is this horizontal line here, you will get the cylinder, which is all together for this shape, shaded and not shaded, the one I will get with the calculation. So the plan is I'm gonna find the two volumes for the full cylinder and then subtract it from this shape I will get by calculation here. So I will result with the calculation for this shaded area. When it rotates, it's gonna get the volume shaded that they are asking for. So let's start. Okay, let's start by finding the volume of the inside first. So the volume for the curve is pi integral from 1 to 2.4, the boundary is on the x-axis, y squared, which is the square of 1 over 5x minus 3 minus 4 power third dx. So I'm going to make this as a power and then do the power rule for integration. This will be pi integral from 1 to 2.4. If you square this, it's going to be 2/3, and raising this up, this will be 5x minus 4 power minus 2/3 dx. Undo chain, I'll do pi times 1 over the derivative of 5x minus 4 here is 5. And using the power rule, this will be adding to 1. So it will be 5x minus 4 to the power minus 2/3 plus 1 is third. Divide a third from 1 to 2.4. This will be, I'm gonna arrange this a little bit. This will be 3 pi over 5 into 5x minus 4 power third from 1 to 2.4 using fundamental theorem of calculus. This is f of b minus f of a, which result with 3 pi over 5. First, I'm gonna substitute x with 2.4. So it's gonna be a 5 times 2.4 minus 4 power third minus 5 times 1 minus 4 power third. Do the calculation and you'll get 3 over 5 pi. But this is not the answer still. We need to find the volume of the whole cylinder, which is pi from 1 to 2.4 of the curve y equal 1. So 1 squared dx. The integral of 1 is x. So this is equal to pi x from 1 to 2.4. Subtract the two things. Pi times 2.4 minus pi times 1. And this is the whole volume, which is equal to 7 over 5 pi. Now, to find the shaded volume, we need to subtract the volume of the cylinder here from the volume of the shape under the curve we calculated earlier. And then the volume shaded will be 7 over 5 pi minus 3 over 5 pi which is 4 over 5 pi. That's it. In question number 10, we have the equation of a circle x minus 3 squared plus y squared equal 18 and the line y equal mx plus c that passes through the point 0, negative 9. Well, here 0, negative 9 is a y-intercept point because the x is 0, which means my c is negative 9, and the tangent to the circle. So there's one point of intersection between the straight line and the circle, like the circle for a sketch and the tangent. There's only one point of intersection. Find the two possible values of m. For each value of m, find the coordinates of the point at which the tangent touches the circle. Well, we have two possibilities maybe. First, let's find the m value. We need to solve this simultaneously. The circle equation x minus 3 squared plus y squared equal 18 and the straight line y equal mx minus 9. I'm gonna substitute the y in here in the equation of the circle, so we will result with x minus 3 squared plus mx minus 9 squared equals 18. We need to start expanding this. X squared minus 6x plus 9, and for mx minus 9 squared, this is m squared x squared minus double 9m, which is 18mx plus 81 equals to 18. If you arrange this equation according to x squared and x, this will be an m squared plus 1 x squared. For the x's, we have minus 6 and minus 18m, so plus negative 6 minus 18 mx, and 9 plus 81 minus 18, this will result with 72. Well, if you do the quadratic here, you can find the discriminant equal to 0 as the line is tangent to the circle. And in this case, we have b squared minus 4ac equals to 0. In this case here, I mean a is m squared plus 1, b is negative 6 minus 18m, and the c is 72. Let's substitute this in the discriminant formula, and then we get negative 6 minus 18 m squared minus 4 into m squared plus 1 times c, which is 72. This is equal to 0. Expanding this and solving for m, you will have 324 m squared plus, which is square of 18 here, and I have 216m. How do we get 216? It's double 6 minus 6 times 18, and for the 6 minus 6 squared, this is equal to 36. Well, you can swap this. Minus 4 times 72 m squared, which is equal to 288 m squared, and minus 288. All of this is equal to 0. Still, we can arrange more. Combine the m squared together. This will be a quadratic. 36m squared, which is 324 minus 288, and we have 216m plus 36 minus 288. This is equal to negative 252 equals 0. And if you factor this, you will get m equals 1, or m equals -7. Now we got two values of m. We have the second part of the question is finding the coordinates of the points for each m. Now for each m, I'm going to go and find the corresponding coordinates. Let's start with m equal 1. Return to the quadratic equation m squared plus 1 into x squared minus 6 into 3m plus 1. To get this, just take minus 6 out in here, plus 72 equal to 0. I'm going to replace m with 1, and then it will give me a 1 squared plus 1 x squared minus 6 times 3 into 1 plus 1x plus 72 equal to 0. Simplify more and you will get 2x squared minus 24x plus 72 equal to 0. Using the quadratic formula, x equal negative b plus minus root b squared minus 4ac, well, this will be a 0 here, over 2a. This will be a negative 24 over 2 times 2. This will give us a 24 over 4, which is 6. So the first x is 6, and the corresponding y here is going to be mx plus c. The m is 1, so 1x minus 9. So 1 times 6 minus 9, which is negative 3. So the first point of intersection in the case m equal to 1 will be 6, negative 3. Now we go to m equal -7 and repeat the working out. We'll get a -7 squared plus 1 x squared minus 6 times 3 into -7 plus 1 x plus 72 equal to 0. Do the simplification here. You'll get 50x squared plus 120x plus 72 equal to 0. Find x again, and this is negative b over 2a as the discriminant is 0 here. And this is equal to, well, there's a way to check your work is correct. You will get the result b squared minus 4a equal to 0. If you want to do this again, never mind. And this will be negative. This is a, b, c here. B is 120, so minus 120 over 2 times 50. This will result with negative 12 over 100. Sorry, minus 120 over 100. This is equal to, as a fraction, this is 6 over 5, minus 6 over 5. Okay, and the corresponding y for this will be y equal mx plus c. Replace m here by -7, so negative minus 6 over 5 minus 9, which gives a negative 3 over 5. So the second coordinate here is when x is minus 6 over 5, we got minus minus 3 over 5, yes. Question 11, we have a graph of the function 4x over x cubed minus 3 over x plus 2. X is never 0. The graph is shown in the diagram. Find the set of values of x for which fx is decreasing. So to find the value of x when the function is decreasing, we have to find the derivative and see where it is negative. Let's start our work here. So I'm gonna consider fx again here. Fx is 4 over x cubed minus 3 over x plus 2, which is equivalent to 4x minus 3 minus 3x minus 1 plus 2. Finding f prime of x, this will be negative, you would multiply the power with the coefficient, so negative 12, x power minus 3 minus 1 is minus 4, and then minus 3 times negative 1 is positive 3, x power negative 2, and the derivative of the constant here is 0. And this is supposed to be negative, so to solve this inequality, this will be minus 12 over x power 4 plus 3 over x squared. I'll solve this equal to 0 first, and then I'm gonna see the final answer. And then you'll get, I'm gonna multiply the whole equation by x4. This will be minus 12 plus 3 x2 is supposed to be negative. Okay, so moving the 12 to the left side, 3x squared is supposed to be less than 12, which means if you divide by 3, x squared is less than 4. Well, where's the values of x that are less than 4 when you square them are the values between minus 2 and 2. And you can check this if you're confused. So x is between negative square root of 4, يعني minus 2, and positive 2. A triangle is bounded by the y-axis at the normal to the curve at the point x equal to 1 and the tangent to the curve at x equal minus 1. Find the area of the triangle. Give your answer to 3 significant figures. Before we start, let's see the plan for this. So let's work step by step. First, we need to talk about the normal at x equal to 1. So imagine with me here you have a certain normal. The normal is always perpendicular to its tangent. So there's a normal line here. Okay. And at x equal negative 1, somewhere approximately here, there's a tangent like this. Okay. Which results in my triangle here. The triangle they are talking about is this one. Well, we have to find 3 basic points. The intersection between the normal and the tangent point. This is a special one. And we need the intersection between the normal and the y-axis. And then we need the intersection between the tangent and the y-axis. Why? Because if I do find these 2 points here, I can find the distance between them, which is the base of my triangle. And this point here to the y-axis, it gives me enough information about the height of the triangle. So the plan is finding the normal equation, finding the tangent equation, their intersection with the y-axis, normal with the y-axis, tangent with the y-axis, and then you find the area. Let's start step number 1 by finding the normal equation. Before we start, to make things easy, I'm going to find the derivative of my function. The function, as you remember, we got the derivative in the previous question. It was minus 12x minus 4 plus 3x negative 2. So when I find the slope or the gradient, it's gonna be easy for me. This is f prime of x that we found in part A. So I'm going literally to start by finding the tangent equation. It doesn't matter where do you start from, but I'm gonna start with the tangent at x equal to negative 1. So I'm gonna find f prime of negative 1, which is the slope of my tangent, minus 12 times negative 1 power minus 4 plus 3 times negative 1 power negative 2. This will give you a minus 9. So negative 9 is the gradient of your tangent. For the point on the line, I need to find also f of minus 1 to get the y for this point. So I'll go back to the original equation, which was 4 over x cubed, so minus 1 cubed. This is not the derivative, this is the basic f. Minus 3 over negative 1 plus 2. So you get the y by calculation, and it will be a 1. Now I will use the formula, or point slope form, or any form you like. I will use y minus y1 equal m into x minus x1. So y minus, my y here is 1. The slope I got is minus 9, x minus negative 1, so plus 1 here. If you arrange this, you will get the equation of the tangent, which is y equal minus 9x minus 8. I will use this later, I'll go back to it. Now we need to find the normal equation. For the normal, the x was 1. So again, we'll find the slope for the normal and the slope, and sorry, the y, which is f of 1, we need it. For the slope, first we have to find the tangent for this normal, and then we do opposite reciprocal. Slope of tangent, which is f prime of 1, do the same calculation as before, but for x equal to 1, this will be minus 12 times 1 to the power of negative 4 plus 3 times 1 to the power negative 2. You will get a 3. No, you will get also a minus 9, not a 3. And then you do opposite reciprocal, which is minus 1 over m, and minus 1 over minus 9, which is 1 over 9. So here, the slope is 1 over 9. And for f of 1, you go and substitute 4 over 1 cube minus 3 over 1 plus 2. And this will be 4 minus 3 plus 2, which is equal to 3. And for your equation, this will be y minus 3 is equal to 1 over 9 into x minus 1. Arrange your equation and you will get y equal 1 over 9x plus 26 over 9. Well, I have a comment here. Once we have the equations, the y-intercept is obvious that this line here will be meeting my y-axis at negative 8, and the normal will be meeting the y at 26 over 9. So if you want to find this distance here, just subtract 26 over 9 minus negative 8, and you got the base of this triangle. And for the height, now we need to go and find the point of intersection between the tangent and the normal. Okay, now we'll start solving the simultaneous equation between the normal and the tangent. So we got y equal minus 9 minus 9x minus 8, that was the tangent, and the normal line, it was 1 over 9x plus 26 over 9. To find your x here, minus 9x minus 1 over 9x is equal to 8 plus 26 over 9. You will result with negative 82x over 9 is equal to 98 over 9. Cancel the 9 here, and the x you got will be equal to minus 98 over 82, which is approximately minus 1.1951. Okay, so now we have, I'll make a sketch without the whole shape. This is 1, the height here is 1.1951, and for this base we're gonna subtract 26/9 minus -8. So for this one is the height, we missed the base. For the base it's gonna be 26/9 minus -8, which is equivalent to 98/9. Okay, one step to go. We need to find now the area of this triangle, which is half BH. So you do multiply the base, which is 98/9, times the height, which is 1 point. You don't take it negative since it's a length side, 1.1951. You will result with the three significant figures, 6.51. That was the whole past paper done, covered. For more videos, don't forget to subscribe and like my channel. Thanks for watching.